All right, welcome to the Calculus Chapter 3.4 recap. I've shut off the camera pending resolution of the annoying flickering. I know you probably don't care, but there it is. So what do we need to know from Chapter 3.4? Well, first off, the definitions. That the average rate of change of a function over some interval can be found by finding the change in the value of the function between x and x plus h and dividing by the change in the input values, which of course is h. So anytime you see the words average rate of change, that is what you are calculating. Instantaneous rate of change. And as it turns out, you don't have to have the word instantaneous. So if you see either the word instantaneous or just the words calculate the rate of change at x equals, then what you are looking for is you are looking for the limit as h goes to 0 of that difference quotient from the previous definition. And that, of course, is also the definition of the derivative. So instantaneous rate of change, derivative, all different ways of talking about the same thing. So language, if you're given some function, any function a of x, then a prime of x, or dA dx, is the rate of change of a with respect to x. And this is really important, because down the road we're going to see functions that have multiple variables, but we're interested in how are they changing in one direction. So all right, what kinds of problems might you see? We looked at particle motion. Particle motion is generally back and forth on some line. You've got some particle and it can go back and forth. What do we need to know? That we have position s of t, that the velocity, which is directional, v of t, is the first derivative of position, and acceleration, a of t, is the first derivative of velocity, which is the second derivative of position. You could also have speed, which is defined as the absolute value of the velocity. In other words, how fast is it going, regardless of direction. And displacement, how far has something moved. And remember, it's always minus its initial value. Vertical motion. Vertical motion is another useful one because we like to throw things or launch things into the air. If we're just talking about free fall, then the position at time t after you drop something can be calculated half gt squared, where g is the gravitational constant. And in Earth's gravity, this is 32 feet per second, or 9.8 meters per second. You should generally be given the value for whatever gravitational field you're in. And if we have an initial velocity, and we're talking about straight up and down here, so you launch something straight into the air, the position can be found using the following. And v sub 0 is the initial velocity. Whoops, I guess I didn't have to write that again. I could have just pointed up at the previous one. And so this is your up motion right here. And then this is what's dragging it back down, slowing it down, as it were. Sensitivity to change. what you want to be able to do is to be able to analyze where is f most sensitive to small changes in x. And finally, economics. We're talking here, we've usually got a cost function, C of x, we've got a revenue function, R of x, and then marginal cost and revenue, C prime, the derivative, or R prime, the derivative of that. And marginal is the rate of change of cost or revenue for small changes in your input, your production, whatever it is. Okay, guys, those are the 4 kinds of problems really that you should need to be able to do. They're all just versions of calculate the average and instantaneous rate of change. But the reason you need to know them is because there is specific vocabulary, and as in any field, every specialized field has its own vocabulary, and so it's useful to be familiar with the vocabulary. They won't necessarily say find the derivative of. If they're an economist, for example, they'll start talking about marginals, and it is on you to know what that means when it comes up. All right, there we go. That was section 3.4 in our AP Calculus book, and thanks for watching.